Alright, what I want to do is explain, first of all, how you can set up your data table, and then how you can take that data and do some statistics with it. So the first thing to notice here is that I've set up the data table with our species here in column A, and I included soil in that, and your list of species might be more than mine. And I also put in the total. This was with 4 transects in areas where honeysuckle has been removed and 4 transects where honeysuckle is still dominant. And so each column here is data that was collected from each of those transects. And so, there were in transect 1, the removed area, there were 13 times we had grape underneath the tape measure. And so because these were 5-meter transects, the total is 50 here. Now your total might be more or less, and it won't really matter as long as you do the math right here. So then, down below, I've got a row for richness, a row for native vegetation coverage, and a row for non-native vegetation coverage. And the idea here is that we're probably not going to just compare the amount of grape in areas where honeysuckle has been removed or where honeysuckle is still dominant. We're probably really interested in the number of species where honeysuckle has been removed versus where honeysuckle is dominant, and the native vegetation coverage and non-native vegetation coverage between those two. So with the richness, I just went through and counted up the species. It was pretty quick and easy just to see that, oh yeah, all 5 were in all 4 of these transects. This one only had 4 because there's a 0 here. These only had 2 because there's 3 zeros in here. Native vegetation coverage, however, I went ahead and put in a formula up here. And a formula is pretty easy to do. Basically, I just told it to add all of these 3 together, grape, fleabane, and goldenrod. Those are the 3 native species. And then divide by the total number of places that some vegetation could have been. And divide that by 100. So it turns out that 13 plus 4 plus 8 is 25. 25 of the 50 total spots had a native bit of vegetation in them. And so 25 divided by 50 is 0.5. Multiply that by 100, it's 50%. And that's what you get here, 50%. So once you have a formula in one box, this is the nice thing about Excel, is that you can just hit Control-C, and then all these other cells, you want the same formula put into, and so you hit Control-V, and the formula is put into all those cells too. I did the same thing with non-native vegetation coverage. Of course, it's just adding up these 2 species, garlic, mustard, and honeysuckle, and dividing by 50. And copied and pasted those into this row, all those columns. So now I've got non-native coverage for all 8 of my total transects here. So this is a nice way of setting up the data table. The next thing you want to do is some basic statistics with your data. And 2 things that you'll want right off the bat would be, what are the averages here, your means for species richness in honeysuckle removed? Hey, that's pretty easy. They're all 5, so the mean is 5. And where honeysuckle is dominant, oh, that's an easy one too. 2 4s and 2 2s. Your mean is going to be 3. Well, you also want to know what the standard deviation is. That's sort of how much variation is there in your data. So if you have all 5s, then, well, there's no variation at all in your data. Here we've got some variation in our data, and so the standard deviation is something that will be useful to us. And what you need to do standard deviation and means is the data analysis tool pack here. It's in the data tab up above here in Excel. Go to the analysis section and the data analysis tools. Well, the problem is that Excel makes this very difficult to find. You may not see it on your computer if you haven't done this before. What you do, if you don't see it on your computer, is you go to File, you go to Options, You go to Add-ins under Options, and then you'll see Analysis Tool Pack. You click on that, highlight it. You don't hit OK, you hit Go down here under Manage Excel Add-ins. Hit Go, and then make sure this is checked next to Analysis Tool Pack. Then you can hit OK. And then when you go to the Data tab, you should be able to see Data Analysis here. Click on Data Analysis, go to Descriptive Statistics, hit OK. And within Descriptive Statistics, you can have it print out summary statistics. That's what you want. So click on that box. Your input range. Let's see, I've already put in an input range, but I'll do it again here. We're trying to figure out the means and standard deviations for these columns here removed. These four. If you do it for all of them at the same time, then it'll average all of the columns. You don't want the average of all the columns. You just want the average of the removed columns, and then go back and do the average of the honeysuckle columns. So I'll do the removed columns first, and since they're right next to the names here, the labels of the removed columns, I'll just go ahead and leave those labels in here too. It'll make it easier for us to remember which is which. When you're doing the honeysuckle dominant ones, you'll just drag over these four columns here, and you'll just have to remember that the top one, the first one was richness, the second one was native vegetation, the third one was non-native. Anyway, we'll just do these three here. They're grouped by rows, right? You're interested in richness, you're interested in native vegetation, you're interested in non-native coverage. Those are rows, and their labels are in the first column here. So we'll hit, oh wait, output range, make sure we have that. And here, we'll put it right here. Okay, we'll hit OK, and there it is. We've got the means, standard area, error, median, mode, all sorts of other things down here. Really the two that we're most interested in are the mean and the standard deviation. So like we said, the mean is 5 for species richness, and the standard deviation is 0 since they're all the same. For coverage for native vegetation, the mean is 50, and the standard deviation is 10.19, and so on. So that was pretty easy. We can figure out mean and standard deviation quickly and easily using the data analysis tool pack and the descriptive statistics. Now what we want to do is figure out whether there really is a difference in the mean between the species richness for honeysuckle removed plots and the species richness for honeysuckle dominant plots here. It looks like there's a difference, right? The mean here is 3, the mean here is 5, but remember that this is just a sample of the total area that was out there, right? You just did, in this case, it's just 4 little transects in a pretty huge area. And so if there's a lot of variation in this data, which there's not, but if there was, and if there was a lot of variation in these data over here, you might think that, well, the mean, if you calculate it, is 3, but boy, it could be really somewhere between 2 and 4. I'm not really all that sure where it is, or it may be a little bit more or a little bit less than 2 or 4. The mean is somewhere in a range of values. The true mean, the true what the actual area on the ground looks like. What you did was just a sample of what's on the ground. What we're really trying to figure out is what is exactly on the ground there, and we don't know, right? We didn't measure every plant out there, right? And so we can't, we can say that the mean is this for our samples, but there might be some slop in the data. And so when you're trying to figure out whether 5 here is really more than the 3 that we got here, we have to look at the variation in the data for both of these. And that's what this computer program will do. We're going to use something called a t-test. The t-test here that we're going to use is well, actually, I think I'll use this one here. The two sample t assuming unequal variances. That's sort of the most conservative one that we could use, and it'll probably work for us. So you click on that, hit OK. Now you input your two variables here. The first variable is going to be where honeysuckle has been removed for species richness. Our second variable, we'll click on this little box thingy here, and then drag over the 4 values for where honeysuckle is still dominant for species richness. Well, there are no labels here that we've dragged over. We'll give it an output range here, so it'll show up on our screen. And our output range, click on the little doohickey there, we'll make our output range right. We'll put it right here. Alright, and we're all set. We'll hit OK. And here we go. Alright, first of all, I think the first thing you should always do when you run one of these tests is to type in what you just did here. This was for species richness, the 2 sample test here. And variable 1 was removed. Variable 2 was honeysuckle dominant. Okay, so the mean is 5 for removed. We already got that. Mean is 3 for honeysuckle dominant. The other things that we need to know here are the degrees of freedom. That's what DF is. The T statistic. This is basically the output of the statistical test that was run on your data here. The T statistic. And then the p-value. What we care about is this two-tailed p-value. The p-value, one way of thinking about it would be what's the probability that these two samples here are really the same, or from actually the same population, right? What's the probability that the honeysuckle removed side over here is really just the same as the honeysuckle dominant side? And it's saying that it's 0.04. That's 4%. That's a pretty low probability. Really, anything under 5%, we say, all right, yeah, they're different, right? This is different than this. We say it's a significant difference, a statistically significant difference. So if it's less than, here I'll type that in, less than 0.05, it's statistically significant. I can't type and think. And that's for that two-tailed p value here. So these 3 things, actually the 4 things on this screen that you're going to need to write your paper would be the standard deviations. That's what you got over here. The means are right here. The degrees of freedom right here. The t statistic right here. And a two-tailed p-value. You're going to need that for everything that you compare. So if you're comparing species richness, you need that. Native vegetation coverage, you need that. Non-native coverage, you need that. If you're wanted to compare the amount of garlic mustard on one side versus the other, you would need those 4 things for that as well. All right, let me switch over to a handout here. And this handout sort of walks you through what I've just done, but what I want to point out here is this is the same type of table that we just saw doing our t-test. Okay, it's got the means, it's got the degrees of freedom, it's got the p-value and the t-statistic. It's for different data, that's why your numbers are different. But this is the type of sentence that you would write in your paper. And you'll see sentences like this in most any paper that you read, something similar to this. And so feel free to use something very, very similar to this in your paper, if it fits. Here's what I'm saying. The number of native plant species found where honeysuckle was removed, that's, we're looking at species richness here. You could have said that. Species richness, where honeysuckle was removed, and then I put in the mean here. That's x. It should have a bar over that x, but I just put in x. That'll work. X equals 986.7 plus or minus the standard deviation. Okay, so that's why you need means and standard deviations. Then I put a semicolon here, and the n value, that's the number of replications that you had. For the last example, it would have been n equals 4. For this data set up here is n equals 10. Alright, so you put that in parentheses after you said where honeysuckle is removed. So you're giving them some results here. You're showing them what the mean is, what the standard deviation is, where honeysuckle is removed. Alright, the number of native species where honeysuckle is removed is significantly greater than, you can say significant, because this p-value is less than 0.05. Okay, notice that this is in scientific notation here. It's times 10 to the negative fifth. Anyway, was significantly greater than the number of native plant species where honeysuckle was still dominant. And I have, once again, the mean here, the standard deviation, the number of replicates. Then, now this is really important here, look at this. Then a semicolon t, because this is a t-test, and a subscript with a 9. Okay, that 9 is the degrees of freedom right here. For our last example, the degrees of freedom were 3. For this example, the degrees of freedom is 9. Whatever your specific instance is, it's basically 1 less than your total number of replicates. Okay, so if you did 5 replicates on each side, then your degrees of freedom would be 4. So you have t, because it's a t-test, a subscript, 9, because that's the degrees of freedom, equals the t statistic. That's this right here. Another semicolon, p, capital P, it's in italics. It's always the way you do it. You always make it a capital, you always make it in italics, and then you put equals the two-tailed p-value here. Notice these look different. This is quadruple 0, 2, 3, whereas this is 2.3 times 10 to the negative fifth. You can write them in either notation. I just took it from scientific notation here to standard notation. Notice I've got some script here in italics. That script is if you didn't have a statistically significant difference, if your p-value was 0.9 or something, you would say that the number of native plant species was the same as the number of native plant species where honeysuckle is dominant. So if your p-value is greater than 0.05, you'd say that there's no difference between those two values. Alright, so you'll do that for each of the things that you're comparing. You'll be writing sentences very similar to this in your results section. This is your support for saying that there is just as much on one side as the other, or for saying that there's more species richness or more coverage on the removed side than the non-removed side. You have to have the statistics in there to back up what you've said. All right, good luck. Whoops. Shift F